Okay, so now we are starting on exponents. So when I talk of exponents, these are in the form of a to the power of b. So what you'll be having here is what we call a base. Okay, then here we call it a power or an exponent. Okay, so that's what we have here. So whatever you have is a power and here is a base. So there are certain laws that you need to understand, okay? Certain laws that you need to understand. Law, what you call law of exponents. So if A, the power B, okay, and A to the power C, we multiplied A to the power C, we check here, we have the same base, then it means that we simply add the powers. Okay. So if the bases are the same, we simply add the powers. So for example, if it is 5 to the power 6 times 5 to the power 7, we just need to add the powers. 6 plus 7 then becomes 5 power 30. That's what we have. That's simply that. So that's what you need to understand here. So what if it is x to the power 6, it is the power 5 times x. This x means it's x to the power 1. So this one is going to be x to the power 5 plus what? Plus 1, which is equals to x to the power 6. I think you have seen there that you have seen previously on our last questions there when we multiply x times x, okay, x times x, we're getting x to the power 2. But so it's x basically x plus 1 plus 1 because there is a power of 1 to the power of 1. So which gives us what x squared, just like that. Okay. Then another rule is x a to the power b. If you are dividing these two, a to the power c, this means that it's gonna be a b minus c. That's what you need to understand here. It's gonna be a to the power b minus c. Okay. Now here, let's have an example here again. So we can talk of maybe we can say it's maybe 3 to the power of 6 divided by 3 to the power of maybe 4. Okay. So what it means that it's just 3 to the power 6 minus 4, which is equals to 3 to the power of 2. Just like that. That's what we have there. Then what else can you think of? X to the power 5 divided by x to the power of 2 is x to the power of 5 minus 2 equal to x to the power of 3. So that's what you need to understand. Okay. So normally it will be given as x presented like this, x to the power of maybe like that 5, x to the power of 2 like this. Okay, as a fraction of this. Then you know that I'm just subtracting my powers there. It's not a big issue here. 5 minus 2, which is equal to x to the power of 3. That's what we mean by that. Okay. Now, so that's number 2. So we put 1 here. We put 2. Right. Now, let's move on to the third one. A to the power of b. Okay. This means that it's a to the power of b times c, which is equal to a to the power of bc. That's what it means. What do you mean by this? So we can have maybe an example of 3 to the power of 2 in a bracket 3. This means that it's 3 to the power of 2 times 3, which is equals to 3 to the power of 6. Multiply the powers. Okay. Then x to the power of 8. Okay, squared is going to be equals to x to the power of 8 times 2, which is equals to x to the power of. Okay. Now let's move on to the fourth one. We're going to say if we say a to the power minus b, this is the same as 1 over a to the power of b. So when you're presenting anything that is the power minus b, you can take it like you can write it like that. So here in this case, it's 1 over a to the power of b. So here we can have an example here of maybe 3 to the power of minus 2 minus 3 is the same as 1 over 3 to the power of 3, which is equals to 1 over 27. So here, then or x power of negative 5 here. Okay, what is it here? It's going to be equals 1 over x power of 6. But now we want to see, all right, why is it the negative there? Remember what we just said, the previous law, that we say x to the power of 5 divided by x to the power of 2 is equals to, we say it is x to the power of x to the power of 5 minus 2. Where is it coming from? Now let's see what's going on here. Now this one is going to be x to the power of 5 times, remember here if it goes up, what's positive here, it's going to be x to the power negative 2. Now what if we are multiplying something with the same place? What do? We add the powers, but here you can see what is going to happen there. It's going to be x to the power of 5, okay, plus minus 2, okay, which will give us x to the power of 5 minus 2, because plus minus will come down. Okay, now here that's what we'll have here. We get what we call x to the power of 3. So just something to master. You need to master this and understand it very well. Okay, now 5. So with 5, fifth one, you're saying any number, anything to the power of 0 must give us 1. Be it 1,000,000, the power of 0, this must give us 1. X the power of 0 must give us 1. So sometimes you be required to apply this knowledge, okay, in an expression where something, maybe an expression is equated to 1, and you need to think of this and say, all right, what should I do there? I think I should replace this 1 with something, with a number that is corresponding in the equation there, what you call with to the power of 0. So that's what it means here. So we'll look at some questions where you need to solve like that. Okay. Now 6 is going to be equal to, when you say a to the power of 1 over n, this means that it's a is n. That's what it means here. So where we have the square root sign here. Okay. So now an example here is when we say 4 to the power half is the same as square root of 4, where you have, so understand this, the square that you see in your calculator, the standard square that you see in your calculator, it means that it's a square. There is a 2, but the 2 is not indicated. Okay, so that's why I say just use square root of 5, square root of 20, square root of 100. You just punch square root only, but the thing is there is a 2 there that you can't see. Okay, now here, so square root of 4, we know square root of 4 is equal to 2. So here what I'm saying here, there is no sign here that shows that it's a square root. Okay, now here what it means here, oh, that's our answer. Then if, let's say, let's say it's 20, it's 64. Okay. Then we have 1 over 3, 1 over 3. This means that it's cube root of 64. Simple like that. Okay. And what it means here, cube root of 64 is 4. That's what we have. Or you can have something like this. Maybe we can say it's, I don't know, we are just saying 125 power of 1 over 5. This is the same as the fifth root. Fifth root. See where I'm putting my 5 there. 125. Then you come here. How do you write this? You are going to say shift. Yeah? Then you put 5 there. Understand this shift x the power where there is nothing there. Yeah, then we bring it close here. So it's shift. Okay. Shift. Okay. Now we have that. Put 5 there. Then you move to the inside there. Put what 125. Okay. And that gives us 2,63 there. So that's what we have 2,63. So that's what you must understand there. All right. Now let's have another scenario again, similar to that. We can relate to that as well. A to the power of m over n. This one is n a n m. That's what it means. So you'll be multiplying a to the power of f of root of I don't know whatever n root is that. Then what we have here, we're going to say maybe an example here. What we can say is that it's maybe 27 or 2 over 3 or 2 over 3. This means that it's cube root of 27 that we are going to square. So here you can write it in any way. Okay, you can write it in any way. You can write it in any way. You can say shift. Okay. You can write it anyway, just like that. Okay, so you can just put it as well like this. Squared, just like that. Or here you can just say it's n, you put the n there, a to the power of m, just like that. That's what you need to understand. So it's not a big deal here. Okay, so here you get what? You get 9. Okay, now another, so that's what you need to understand here. That's basically what you need to understand with indices. That's what you need to understand with indices. Let's try to check some of the what you call some of the challenging questions that you can be presented to you. Okay, I just left something here. A over b, okay, to the power of n. Maybe let's just say the power of m n. Okay, it means that it's a to the power of n over b to the power of n. So all of them will be sharing the same power. That's what it means. So let's have an example here. We can say 2 over 5, okay, power of 2. Okay, this means that it's going to be 2 squared over 5 squared, which is going to be 4 over we have there. What else can you think of? So if it is maybe 2, or maybe let's say uh, x, maybe let's say it's 4/7 above -1. Okay, that means that all of them should be 4 for -1 over 7 for -1. Then if it is 7 to the power -1, it means that it has to go up to be positive. Then 4 -1, it needs to go down. So it's gonna be basically it's gonna be 7 over 4. That's will be your answer there. Okay, that's what you need to understand there. Then if it is x the power 6 over x the power maybe 5, and you are putting bracket, we are putting them in bracket like that. 3, it means that it's going to be x to the power 6 times 3 over x to the power 5 times 3, where we get x to the power of 18 and x to the power of 15. That's what you get there. And when you get there, when we say now it's x to the power 18 minus 15, which is equal to x to the power of 3. So that is there. Okay, so that's what we have there. So we're dealing with such scenarios: x the power 6 over x the power 5 the power 3. Then you multiply there, because you understand that here what it means here, what we have there is sort of like x the power 6 in the bracket 3, okay, over x the power 5 in bracket 3. So in this case here, you need to multiply the powers. That's how we get the answer here. Okay. Okay, let's see how we can solve this. It's 9 to the power of half. 9 to the power of half, remember, the same as square root of 9, which is equal to 3. Root of 9 equal to 3. Then 8 to the power is going to be equals to cube root of 8. Okay, then what do we have here? We're going to get, what is it? Cube root shift. Sorry. Get it to there. Then now we are given, when you're given something like this, now you need to think of what you call having an expression with what you call with the what you call all exponents with same base. So find it to have same base here. How must you have same base here? Like a base of 4. Okay, that it can be easy for you to deal with it. Because remember, everything that we're doing here, everything that you're dealing here with our the theorems here that we are arranging here, you find that you need the basis needs to be the same for it to apply. The basis needs to be the same. So here, what you're going to do here, you're going to say, all right, this is 4, the power n plus 1. Now that one is fine. But how do you get it to? How do you get it to, what is it? How do you get it to 8? So in other words, all right, let me say here, this is the same as 2. The simplest here is going to be equals to 2 to the power of 2, which is equals to 4, okay, n plus 1. Then times 2, to get 8 is supposed to be 2 to the power of 3. So 2 to the power of 3, okay, in bracket here, 2n, okay, all over 16 is going to be equals to 2 to the power of what? So we say 2 times 2, okay, so it's 2 to the power of 4, bracket here, n minus 1. That's what we have there. Okay. So now what will be having now is that since you have got two, you've got two base of two, you just need to simplify there and you see that it's gonna be 2 to the power. Since this one is supposed to multiply ours is outside there, it's gonna be 2 n plus 1 times 2 3 times what 2n over 2 4 2n minus 1. Okay, that's what we have there. I'll sort it out later. Yeah, then what we have here, we're going to simplify there and say 2. Since 2 is the same base here and the same basis that you can see here, so it means that it's going to be, we're going to add the powers for these two, 2 to the power of what? Of 2n plus 2 plus, here it's going to be 6n, but now minus, because this whole thing is below is under the denominator, minus 4 4 times 2 is 8n, 4 times negative 1 minus 4. And what we get here, we're going to say 2n plus 6n, get 8n. 8n minus 8n, get a 0. So the answer we're having 2 here. And what we have here, we're going to say it's going to be 0 plus 2, okay, 2 minus 4, get minus 2. What it means here. Then what we have here, we're going to say 0, it's going to be just 2 to the power of negative 2, which is equals to 1 over 2 squared, which is equals to 1 over 4. That's how you get the answer there. So that's how easy it is to get the answer. Now here again, here you can be given something like this. Here. It's x plus 3 minus 3x plus 1, okay, over 3x plus 1. So here we are saying minus. Remember, we're saying minus here. There's no application sign there. So here we need to convert. We need to have same thing here, like what is it? 3 to the power of what is it? X the power x1. So you can must have the same power here that you can do the factorization here. So now let's see what's gonna happen now. X the power of, now here 3 x the power x plus 3, it means that here it was x to the power, what is it? X to the power x 3 to the power 3 to the power x times 3 to the power 3, of which 3 to the power 3 you can express it in other ways, as well. And this is the same as x plus 3, sorry, x plus 1, okay, plus 2, okay, minus 3x plus 1 over 3x plus 1. Now, remember we are fighting here to have 3x plus 1, x plus 1, even here as well. That's what we are fighting. So that we can be able to divide when they have the same power there, okay? Now, what is it? What we have here, we're going to say right here, what it means here, it means that from our first, what is it? Our first, over there, that's 3x plus 1, okay, times 3 squared. That's what it means, okay. minus 3x plus 1 over 3 to the power of x plus 1. So now, as you can see, here is now common. Okay, this is common now, 3x plus 1. This one also, so it's going to be 3x plus 1 outside. Then you get 3 squared minus 1 over 3 to the power of x plus 1. That's what you'll get there. So here it means that this will cancel, okay? And you're left with what? 3 squared minus 1, which is equals to 9 minus 1 equals to 8. That's what you get there. That's your answer there. So just remember here that you can also separate, and when you separate, you are using this theorem that saying a to the power of b times a to the power of c is equal to a to the power of b plus c. So what you're doing now, you're coming from the b plus c to this. So that's why we have to say, all right, this means that this whole thing here means that it's 3x plus 1 times 3 to the power of 2. That's what you have, 3x plus 1 times 3 to the power of 2. That's what it means there. So even if you want to use this one to multiply it, all right, to solve this one, remember they are same basis, so you just add the power, so it's going to be x plus 1 plus 2, which is going to be x plus 3. Then the original one from our original equation is. Okay, that's what you need to understand there. You need to be able to convert such things. Okay, so let's just try to check some equations. Okay, so here's 2 to the power of x is equals to 8, and you are asked to solve for x. You want to solve for x. So here's the trick here. When you are given such equations, you need to make sure that you have same base both sides. Okay, you have same base. So we know that very well that 8 is what you call 8 is the same as what you call is can 2. 8 is 2 to the power of 3. We know that because if we try to punch here 2 to the power of 3 we get 8. Okay, so it means that it's, so we can express 2 to the power of x and express 8 as in the form of 2 is to the power of 3, just like that. Then once we have got the same basis, okay, remember powers should also be equal. So here, therefore here, your x is what is 3. Done. So you just have to equate the powers only. That's what you are doing only. Exponents, equating the exponent. That's what you're just doing there. Okay. Then in this case again, you're gonna do the same principle here. Okay. But you must have the same base both sides. So it's gonna be 5 to the power of 2 plus 1 equal to 5. Now 125 is 5 cubed, if I'm not mistaken as well. The power of 3 is 125. Okay, 5 to the power of 3 is what called is 125. Okay, that's what we have. It's 5 to the power of 3 is 125. Now 125. Now it's gonna be 5 to the power of 3. Then once you're given something like this, you are now equating, because since the bases are the same, you're going to say 2x plus, sorry, 2x plus 1 is equal to 3. Simple as that. Then 2x is equal to 3 minus 1 is going to be 2. Then x is 1 because you're going to divide it with both sides with what called with x. That's what it means. Eh? Then you found the value of x like that. Now, here is another scenario here where I think I once said this, where we are given a the power of x times a to the power of x plus 5 times a is equals to 1. What is going on here? Remember here, if we've got 1, it means that because we need the same basis here for us to solve what you got to solve this. So 1 is the same as this one, a to the power of 0 should be also equal to 1. That's what it means. So what must we do now? We're going to say it's a to the power of x times a to the power of x plus 5 times a. And when it's just a like that, it's a to the power of 1. Okay, just for you to understand. Then a to the power of 0. Now, remember, we're supposed to equate everything here to 0. So we're just going to write all the powers, where the powers should be also equal. So we're going to say x, since these two are multiplying, it's going to be x plus 5 plus 1 is equal to 0. That's what we have there. Okay, because 1 is there and the 0 is the one that we have there. Now it's going to be 2x. Okay, we can just transfer these ones, these two. 5 plus 1 is 6. It's going to be equals to negative 6. Then we divide by 2, we divide by 2. X is going to give you 2 into negative 6. I give you negative 3. That's your answer. That's your final answer. You understand here. Now, let's check here something else again. When you're given something like this, 2x to the power 3 over 2 is equal to 54. First of all, get rid of these 2. Okay? So you divide by 2, you divide by 2. Okay? Then what happens then? Then it's going to be x to the power 3 over 2 is equal to what? Is equal to 54 divided by 2. Let me see. 54 divided by 2, you get 27. Okay? Right? 27. Okay? Now, in this case now, there's something that you need to understand here now. When you're told that x squared is equal to 25, okay, this means that for us to remove x to the power 2 here, we must multiply with the power of half, to the power of half, both sides, okay? So it means that generally it's x squared, x is going to be equal to root of 25. So if it is x to the power 3 is equals to 27, this means that it's going to be x is going to be equal to cube root 27, because you're just going to remove this 3 by cubing this side and you also cube this side. Then your x here is going to be equal to 3. That's what we have there. Okay. Now let's move on here to see what's supposed to happen here. So if it is like that, you must multiply with the reciprocal. Now what we have here is going to be x to the power of 3 over 2, okay, times multiply to the power of 2 over 3. So that if you multiply this, 2 over 3 is going to eliminate this, is equal to 27 to the power of 2 over 3. Okay, what does this mean? This one will give you 1, because 3, 3, 2, 2. So this one will give you 1. So what are you going to do now? You're going to say, all right, x to the power of what? X is equal to, remember, cube root of 27 squared. This is, remember what we said here, x to the power of m over n is equal to what? N x to the power of m, whichever way you want. Now here, we're going to say now, we're going to write this. We'll write this and say shift. Okay, what do you have then? 3, 27 squared. So this one will give us 9. So that's how you must solve these equations. You must always think of what should I do, what should happen, okay? And being able to apply them from even the reverse, okay? From what you call like in this case here, 5 to the power of 2x plus 1 is the same as, what is it, 5 times 2x times 5 times what equal times 1, okay, the power of 1, sorry. That's what it means there, okay. Okay, so let's get to see, what are sets here. Sets are these expressions without a root, or what is it? So they do not have, they are not perfect squares. Okay, so for example here, root five. Root five is a set because if if you want to say root five, you're going to get it as a fraction there, okay, or as a decimal. Root 20. So whenever they say leave your answer as in set form, it means that you must have the root there. Okay, you must have the root there. Okay, so it's like this one. If I'm asked to leave this as what got in set form, I'm gonna say, okay, this one is gonna be equal to root of 5 times 4, because I know that 20 is equal to 5 times 4. But now understand something here. When you're multiplying something like this, you're going to say, all right, it's going to be root 4 times root 5. That's what it means. Then here, the 4 does have a root, which is 2 root 5. So when you're root punching root them and saying, what is it, root 20, you find that is 2 root 5. So if they say leave it in set form, you leave it like that. If they say it's two decimal places, you know that, oh, they must give it as a fraction, as a what called a decimal like that. That's what we call roots. And if you multiply, so said, if you say 3 times root 3, this must give us 3. Okay, so like 8 to the power of a root a times root a root a must give us a. Okay, what's going on here? Let's check something here. 3 to the power of 3 root 3 is the same as 3 to the power of half times 3 to the power of half. Okay, then how do we get that? We know that the bases are the same, so we get the powers half plus half, which is equals to 3 to the power of 1, which is just 3. That's how you're supposed to understand it. So whenever you multiply what you call what you call these sets, you know that, all right, I'm going to get the whole number like that. Okay, so um, the other thing as well is like when you're given, let's say, an expression, okay? When I give an expression here to say uh, root, okay, x, maybe root x plus 3 is equals to, maybe is equals to 2. Okay. Now, when I give it something like this, so you're asked to solve. So these are set equations. When you're asked to solve such scenarios, you know that, all right, how do I remove what you call, how do I remove the sign? I need to square all everything. So what do you do here? You're going to say root of x plus 3, okay, is squared is equals to 2 squared, okay? Then these two will cancel since x plus 3 is to the power of what? Is the power of half. And now, because of the root times 2, this will cancel, and this one give us 4. So these two will cancel here. So you be left with x plus 3 equal to 4. Then x will be equal to 1. Now, that's what you need to understand there. That's what you just need to understand there. You might just mind those expressions. You just try to check which other what will set equation that you can have. Okay. So I just extract this from November paper 2018. Now, here it's given that what you call, you're solving for x here. It's root 3 minus 26x is equal to that. So what you need to do is just 3 minus 26x is equals to, you are squaring everything. Yeah. Okay. here, we are squaring everything, we are squaring everything. That's what we have here. So it's gonna be 3 minus 26x is equal to 9x squared. So we take everything, that's gonna be 9x squared plus 26x minus 3 is equal to 0. Now here, this is now a, what is it? This is now a trinomial. You need to factorize this. You need to solve this quadratic equation now. Now, if we say do a factors here, let's see what we can do here. Okay, let's take the first and the last. That give us negative 27x squared. Okay. Now, what must we do here? We know that we replace that, what we call, we need two factors here. That if we multiply, we get 27. If we add them, we get 26. So it's gonna be 27x and 1x and negative x. So these two here, if you multiply them, they give you negative 27. If you add them, it's gonna be 27x minus x, is gonna give you 26x. So we're going to say 9x squared plus 27x minus x minus 3. Okay, and remember, you treat this separately, you treat this separately. Now this first two here, you factor out 9x outside. Then if you factor out 9x outside, what are you left with inside? You're going to left with x plus 3. Then here you have to factor out negative 1, negative 1. Then what are you left with inside? You're left with x plus 3. Then what are the factors here? Remember, we're still equating to 0 here. Gonna be x plus 3, 9x minus 1 is equal to 0. Okay. Then your x is equal to negative 3, or your x is equals to what we call 1 over 9. That's what we have there. These are the answers that you must. So it's either 9x minus 1 is equal to 0, or x plus 3 is equal to 0. When x plus 3 is equal to 0, you get x equals negative 3. Then when 9x minus 1 is equal to 0, you get x equals to 1 over 2. Simple like that. So that's how you're supposed to solve. So now it becomes a quadratic equation, okay, to worry about now. So that's why I said you need to master your quadratic formulas using the factoring and also using quadratic equation. Okay. Now, so here's another example here that we have presented to you here. So we have told that x3, you're solving for x here, 3 plus root x minus 1 is equals to 3 is equals to x. So what must you do now? You must first say, all right, you move 3 that side, it's going to be x minus 1 is equals to x minus 3. Okay. Now what do you do? Remember what we said, it's going to be x minus 1. Now you need to, when you get used to this, you don't need to worry anymore, because you know that for me to remove the equal there, that root sign here, I just need to square both sides. Okay. Now what must we get there? You're going to deal with this one now. X minus 1 is equals to x squared, then x times negative 3, you get negative 3x times 2, negative 6x, negative 6x plus 9. That's what you get there. Now, if you are to you take this what you call your x minus 1 that side, it's going to be x squared minus 6x minus x, okay, plus 9 plus 1 equal to 0, because 1 becomes positive that side. Then here it becomes x squared minus 6 minus 7x, okay, plus 10 is equal to 0, like that. Okay. Now you need to think of, all right, what are the factors here? Remember, take this, multiply 10x squared. Two factors, we multiply them, they give us 10. We add them, they give us negative 7. So it's gonna be negative 5x, okay, and negative 2x. If you multiply these two, negative and negative, it will be positive. If you add them, they give you negative here. Now it's gonna be x squared minus 5x minus 2x plus what? Plus 10. Remember these two factors replace the middle number. Now here, what we have here, let's treat this separately. Let's also treat this separately. So what we're going to do here, we're going to say x minus 5. And then now here we factor out negative 2x minus 5. Now same values here, x minus 5, okay, and x minus 2. These are equal to 0. Equal to 0 is an equation, remember. Now here either, you know that x minus 5 is equal to 0 and x is equal to 5, okay, or x minus 2 is equal to 0, then x is equal to 2. Then that's how you solve what call such questions like said equations. You are required to know this because it comes in exam. Okay, so take everything serious here. Whatever we've done in this lesson, what is it? Whatever we've done in this lesson, what called the exponents and the sets. Those are the things that comes in the exam. That's what will be tested. So try to find some examples, some questions to do, and you will be fine there. Okay. So thank you so much. Until next time.